Okay, now that we have our two equations, we can actually solve these. And we'll look at our steps. First step, do we need to get an x or a y by itself? Well, we already have y by itself in both of these. So no, we don't need to do that. Step number 1 is done. Step number 2, substitute an expression for x or y. Well, we have y equals in both of these. So this is actually the type we've already seen earlier in the year, but we can use that same idea as substitution. We can take this, and this is equal to y. Well, we have a y down here. So it's the same idea, you're really just plugging that in. But what that actually becomes is you're just writing those two equations equal to each other in this particular case. But the same reasoning is that same reasoning as substitution. You're substituting this expression for the y over here. You could do that either way, it doesn't matter, although what happened is these two would flip around. If you put this one up here, it would just change that. It just doesn't change anything. Okay, now we can actually solve this for the first variable. Okay, and this is the situation where you have the x's on both sides, so you need to make sure you get an x on to one side. If you're having any trouble with this, just let me know, but I think most of us can get through this pretty quickly. So we have 7x minus 4x is 3x. We still have minus 7. We have equals, and we have the negative 3 here. Now we have 3x minus 7. Well, there's a minus 7, so you need to add 7 to both sides. Okay, negative 3 plus 7 over here is 4. Still have our equals. Those canceled out. Negative 7 plus 7 is 0, so they don't need that anymore. We have 3x equals 4. So finally, you're going to go ahead and divide both sides by 3. Divide both sides by 3. And so we have x equals 4 over 3.